So, we're in chapter 8 to 8.1. Pythagorean Theorem. So let's draw a triangle. Basically, we'll draw the picture we had for our opener. So here's my triangle, and there's my 90-degree angle. And we're going to say for any right triangle. And we're going to say our legs are A and B. And we're talking about the lengths here, so our lengths are A and B. And hypotenuse C, A squared plus B squared equals C squared. The hypotenuse of a right triangle is always the longest side. So to be able to pick it out, so our hypotenuse is always the longest. And the other way we can remember where the hypotenuse is it is opposite the right angle. So across the triangle from the right angle. So this is true for any right triangle. And like I said right when we started, the Pythagorean theorem, probably the most important theorem, one of the most important ideas in all of math. It's been around. It's named for Pythagoras, who was a Greek, but it's been around for a long. It was around for a long time before Pythagoras, as far back as like 1700 BC. People knew about the Pythagorean theorem. Ancient Babylon. There are writings in ancient Babylon that say that the ancient Babylonians knew about the Pythagorean theorem. In ancient Egypt, they would use the Pythagorean theorem they used it to figure out the lengths and sides of their land. So it was really important for surveying, for measurement. So there's Chinese writings with the Pythagorean theorem, numbers that work in the Pythagorean theorem on it. So it's been a really important idea for a long time. It's kind of like pi and circles with the relationship. So it's really one of the really important ideas in all of math. So what we want to do today is just work with some ideas from the Pythagorean theorem and go a little bit further with what we can figure out if we know the lengths of sides of triangles. So let's do a couple of examples with the Pythagorean theorem, doing some calculations, and then we'll take the Pythagorean theorem just a little further. So any questions about the Pythagorean theorem? All right. So a couple of examples. So the easiest problems just give us some sides, and they ask us to find sides. So let's do a couple of those. So we're going to say this is 15 centimeters, and this is 8 centimeters, and we want to know how long that side is. So what I'm going to recommend for the Pythagorean theorem is label your sides A, B, and C, so you put your numbers in the right place in the Pythagorean theorem. So on this triangle, which side is going to be C, which is our hypotenuse? A question mark, the one we're trying to find. So I'm going to call this one C. And does it matter which one we call A and B? We can call either one A and B. So I'll call that A and that B. Doesn't matter. So this lets us plug our numbers into the right place. So I'm going to say 15 squared plus 8 squared equals c squared. And then we calculate. So 15 squared, if we plug that in our calculators, this says 225. 8 squared is 64. And we get c squared. Add these two together, 65 and 225 is 289. Equals c squared. I'm going to turn it around and take the square root. To undo a square, we take the square root. So c is the square root of 289. Anybody happen to know what that is? Without calculating? Some people know some of the perfect squares. So square root of 289 turns out to be 17. So c is 17 centimeters. So questions on that one? Pretty easy calculating with Pythagorean theorem. Now we won't always have numbers. Sometimes we'll have x's in there and we'll have to solve for x. But the procedure is always the same. Find which sides a, b, and c, plug it into the Pythagorean theorem, and then solve for the part that you need. All right, let's do another example. So here's our triangle this time. Here's my right angle. Here is, we'll call that x, 10, and 16. And we want to find x. All right, so let's label our sides. So which side is our hypotenuse here? 16. We don't know the length of this side, but we know this one is opposite the right angle. So that tells us that that's the hypotenuse. So that's C. Do we want to call x A or B? A, B? I'll call it A. Doesn't matter. I heard B first. Someone over here said B before you said A, so that's right. So we're going to say a squared, so x squared plus 10 squared equals 16 squared. So that's why, this is why I want, it's helpful to label the sides. So we put the x, we put the part that we're looking for in the right place. Because a lot of times what students want to do is they always want to put the part over here that we're looking for over here for C. But we're not always looking for C. So x squared plus 10 squared is 100. 16 squared is 256. Subtract 100. And I get x squared equals 156. Take the square root of both sides to undo that square. So x equals the square root of 156. And this, unfortunately, doesn't come out nice and even. So let's simplify the square root. Let's write in simple radical form. So one trick that I use for this, and I think I've showed it to you before, call it upside down division. I gave it away. So we want to divide this number by the smallest prime number that will divide into it. So I know 156 is even, so I know we can divide it by 2. 156 divided by 2 is 78. We can divide 78 by 2, and we get 39. We can divide this by 3, and we get 13. Well, 3 or 13 we can't take the square root of easily, so I'm just going to leave it. We can't take the square root of either of those easily, so I'm going to leave it like this. So when we do this method, what we're left with down here stays in the square root. And if we have a pair of numbers out here, one of the numbers from the pair goes in front of the square root. So 150 square root of 156 equals 2 times the square root of 39. So we do this upside down division. Whatever we're left with down here stays in the square root, and for each pair that we have out here, one of the pair comes in front of the square root and multiplies. Which part? When we want to, if the question asks you in simple radical form, they want you to only leave inside the square root a number that you can't take the square root of evenly. Okay. So you want to reduce it down until you get to something like this, where the number inside the square root, there's nothing left inside that we could take the square root of evenly. Because when we said that 39, that's 3 and 13, and we can't take the square root of either of those evenly. So we want that's all we want to leave inside the square root. Okay. And it's one of the things that when we write an answer, it's kind of a convention, so we always do it the exact same way. So everybody's doing it. Mathematicians do it so that we always write the answer in the exact same way. If the question wanted an approximate answer, we would plug this into our calculator and just get a decimal for square root of 156. All right, questions on that example? Okay. So let me go back here really quickly. This first example that we did, where we had our sides were 8, 15, and 17. We give a special name to whole numbers that work in the Pythagorean theorem. And by whole numbers, I mean not a fraction, not a decimal, that kind of thing. So we call those Pythagorean triples. And Pythagorean triples are 3 whole numbers that work in the Pythagorean theorem. One of the easiest ones, one that a lot of people remember, is 3, 4, 5. So the numbers 3, 4, and 5 work in the Pythagorean theorem. 3 squared is 9, 4 squared is 16, 9 plus 16 is 25, and that's 5 squared. So that triple of numbers works in the Pythagorean theorem. Another one that's pretty common is 5, 12, and 13. 5 squared plus 12 squared equals 13 squared. Another one is 8, 15, 17. And another pretty common one is 7, 24, 25. So these are 3 whole numbers that work in the Pythagorean theorem. So if you can remember, especially the 3, 4, 5, math classes like to use 3, 4, 5 triangles. You can remember that a 3, 4, 5 triangle is a right triangle. That'll really help you out. And multiplying any of these triples, yes? Multiplying any of these triples by a whole number gives us another Pythagorean triple. So if I multiply this 3, 4, 5 triangle by 2, multiplied everything by 2, I could get a triple of 6, 8, 10. That would be a Pythagorean triple. It's 2 times this one. I could multiply this one by 2 and get a 10, 24, 26 triangle. And that would be a Pythagorean triple. So any of these I multiply by a whole number. I could multiply it by 3, I could multiply it by 4, I could multiply it by 100, and I would get another Pythagorean triple. So just a quick way of finding numbers that work in a Pythagorean triple. Yes.
Wait, so these are the sides of triangles?
Sides of right triangles. If these were sides of a triangle, it would be a right triangle. The which one?
The second.
Oh, this is 3 times 2, 4 times 2,
Can we do any number?
and 5 times 2. Any whole number.
3 times 12.
Yep. And that would give us another set of sides of a right triangle. It would be guaranteed that it would work in the
And
Pythagorean
not
theorem.
every side is like this, so I don't think
Not every,
every triangle.
no, not every triangle is like this. We just give a special name to right triangles that have whole numbers for sides. So there are no fractions, there are no decimals. So we call, if all 3 sides are a whole number, we call that a Pythagorean triple.
So it's not in like special order.
Not in a, well, the hypotenuse is always the longest side.
Yeah.
Yeah, but other than that, it's not in a special order.
2, 7, 42.
That wouldn't be a Pythagorean
No,
triple.
would?
Would not.
Why?
Because 2 squared plus 7 squared doesn't equal 46 squared.
Okay, so it has to be.
It has to work in the Pythagorean theorem.
Oh, okay.
Okay.
So
Okay.
3 squared plus 4 squared equals.
5 squared. Yes. Because
Oh, I thought it was just like.
no. So these are numbers that work in the Pythagorean theorem. That's why I wrote they work in the Pythagorean theorem. 3 squared plus 4 squared equals 5 squared. 5 squared plus 12 squared equals 13 squared. 8 squared plus 15 squared equals 17 squared, and so on. So these all work in the Pythagorean theorem.
So then for the bottom numbers, that's just a whole other.
So this would be another set of numbers that work in the Pythagorean theorem.
So like 6 squared plus 8 squared.
Equals 10 squared. Yep.
But then, so why do I need to know like 3 times 2?
Because this, what I was saying is that if I multiply any of these triples, each one by the same whole number, I get another set of numbers
Right.
that is a Pythagorean triple.
Oh.
So I multiplied all of these numbers by 2,
Yeah.
and I got this set of numbers.
Right.
I multiplied all these numbers by 2, and I got that set of numbers. And this set of numbers also, 10 squared plus 24 squared equals 26 squared. So that one works.
Constantly need to be thinking about that.
It's more if you can remember this one. That one's a really good one to remember because that one comes up a lot. And the 5, 12, 13, if you can remember that shortcuts you some work.
Okay.
So if we have 3, 4, and 5 as a right triangle, you'll know right away, oh, that's a right triangle. If you have 3 and 4 as 2 sides of the triangle and you want to find the missing side, if you know that this is a Pythagorean triple, you say, oh, the missing side's 5.
Okay.
And you don't have to plug it into the Pythagorean theorem.
Okay.
You just know that works. Okay, does that help?
Yeah.
All right. And the hypotenuse again, the hypotenuse is always the longest side. So now we want to do a little bit more with the Pythagorean theorem. So we want to go the other way. We want to decide if we have 3 numbers, like Jordan said, if we have 3 random numbers, do we know if it works? Do we know if it makes a right triangle? So that's what we're going to talk about next. So this is the converse of the Pythagorean theorem. Oops. So the converse says that if we have a triangle with sides A, B, and C, and C is the longest side, if A squared plus B squared equals C squared, then we know that it is a right triangle. So this gives us a way to figure out if we just have 3 lengths of sides, do we have a right triangle? So with the Pythagorean triples, we know already that those make a right triangle. But if we gave some random number like the ones that Jordan gave us earlier, that's how we test if we have a right triangle. So if we know that we have a triangle with sides 12.5, 30, and 32.5. And our question is it a right triangle? So anytime a question is asking you, is it a right triangle? The real question is, do the sides work in the Pythagorean theorem? Is it a right triangle is asking you, do the sides work in the Pythagorean theorem? So we test it. So with these side lengths, which side would be C? 32.5. So I'm going to call that C. And I can call either one A and B. So I'll just do it in alphabetical order, A, B. And I try it out in the Pythagorean theorem. So I'm saying 12.5 squared plus 30 squared. I calculate that out. 12.5 squared plus 30 squared is 156.25. That's 12.5 squared. And 30 squared is 900. And that equals, when I add those together, 156.25. So that's A squared plus B squared. 1,000, did I write? 1056. There we go. 1056. So this is A squared plus B squared. And we're trying it out. We're seeing, does that equal C squared? So we say 32.5 squared. We plug that in our calculator, and our calculator tells us 1056.25, and that is C squared. So A squared plus B squared equals C squared. So the triangle is a right triangle. If the two numbers, if A squared plus B squared is not exactly the same as C squared, if this were 157, it would not be a right triangle. So if the question says, is this a right triangle, they're saying, do the sides work in the Pythagorean theorem? If they do not work in the Pythagorean theorem, then the triangle is not a right triangle. So questions there? And now the next piece we want to do is say, well, if it's not a right triangle, what kind of triangle is it? Is it an obtuse triangle, meaning the angle is bigger than 90 degrees? Or if it's an acute triangle, the angle is smaller than 90 degrees. So if it's not a right triangle, what kind is it? That's what we'll talk about next. And these are the Pythagorean inequalities. All right, so we have a triangle. And for triangle ABC, with sides A, B, and C, and C is the longest side. We have three possibilities. One is the one we've already talked about. If a squared plus b squared equals c squared, what kind of triangle do we have? Right triangle. So if the Pythagorean theorem works, we have a right triangle. If c squared is greater than a squared plus b squared, so c squared is bigger, then triangle ABC is an obtuse triangle. And the way I visualize this is I make the triangle with my hand. A squared plus b squared equals c squared, right triangle. If c is bigger, I'm making that long side longer, we get an obtuse triangle. And we can draw a little picture here just to remind us what an obtuse triangle looks like. An obtuse triangle looks like this. So this would be side C. This long side would be side C. So if it's too long, if side C is too long, if c squared is bigger, then we have an obtuse triangle. And if c squared is smaller, then we have an acute triangle. C squared is less than a squared plus b squared. Triangle ABC is acute. And the way I visualize that is right triangle. If c squared is too small, then my triangle, the angle gets smaller, I get an acute triangle. And if we draw a quick picture, just to remind us what an acute triangle looks like, we're talking about a triangle that looks like that. And this would be side C. C is too small to make it a right triangle. Whoops, that's not side C. This is side C. The long side of side C. And I didn't even make my triangle acute. Acute triangle would look like, let me redraw my acute triangle. There we go. So that's going to be side C. Side C is too short to make that a right triangle. So obtuse, c squared is bigger. Acute, c squared is smaller. Right, c squared and a squared and b squared are exactly the same. This is how we figure out what kind of triangle we have if the Pythagorean theorem doesn't work. Pythagorean theorem works, we have a right triangle. If it doesn't work, we have an obtuse or an acute triangle. Questions there? All right, let's look at a couple of examples of using this. Then that's the last thing we need to talk about for today. So for all of these, our question is, what kind of triangle? And by what kind, we mean right, obtuse, or acute. So our sides are 14 inches, 7 inches, and 9 inches. So for these sides, which side is going to be C? 14, always the longest side. C, and I'll call that A and B. So we find C squared, and we compare it to A squared plus B squared. So C squared is 14 squared, which is 196. And then 7 squared plus 9 squared, and that's a squared plus b squared, equals 49 plus 81, and that equals 130. So this tells us, is c squared larger or smaller? C squared is larger than a squared plus b squared. So what kind of triangle do we have? obtuse. C squared is bigger. So our triangle is obtuse. So that's an obtuse triangle. And this, so going back to the Pythagorean triple, because these three whole numbers do not work in the Pythagorean theorem, they would not be a Pythagorean triple. How about 2.5, 6, and 6.5? All right, which side is C here? 6.5. So we'll call that A and B. So C squared is 2.5 squared, which is 6.5, yes, thank you. 6.5 squared. C squared is 6.5 squared. 6.5 squared is 42.25. And then we're going to do 2.5 squared. Plus 6 squared. And that's A and B. A squared plus B squared. And we get 2.5 squared is 6.25 plus 36. When I add those together, I get 42.25. So A squared plus B squared is 42.25. And what do we see? C squared equals A squared plus B squared. And we get a right triangle. So that triangle turns out to be a right triangle. All right. Let's look at one last example. 2, 3, and 3.5. And we want to see what kind of triangle this is. So which side is C here? 3.5, that's going to be C here. So that's going to be A and B. So we try A squared plus B squared, see if it's C squared. So C squared is 3.5 squared. And that's 12.25. 2 squared plus 3 squared, and that's A squared plus B squared. So I get 4 plus 9, which is 13. And we get C squared is less than A squared plus B squared. So that tells us we have what kind of triangle? Acute. So our triangle is an acute triangle. All right, questions? Questions on Pythagorean theorem? A squared plus B squared equals C squared. Right triangle. And then we have the Pythagorean inequalities that tell us whether we have an obtuse or an acute triangle. All right. Let me write the homework down really quickly. We will go over our common core practice. Oh, I don't have it written up there. So let me stop this.